So today, welcome back. Today we are going to be looking at tacit collusion. We're having a look at how game theory and the Kinked demand are kind of all the same and answer a lot of questions that you have. So the first question that you had that was an outstanding question, so happy with this question, is about tacit collusion. So one of you asked me, is tacit collusion and Nash equilibrium the same thing? And that's what we're going to look at first today. So what I want you to think about is just pause the video and just think to yourself whether that is the same thing, whether you think that Nash equilibrium and tacit collusion are the same. So the way we're going to have a look at that first is by looking at this game theory matrix here. So what I suggest you do is just pause and try and find the Nash equilibrium. So I'm just going to remind you of what the Nash equilibrium is. So the Nash equilibrium is where neither party, so A or B, can move their strategy and be made better off, right? So where is that on this game theory matrix? Here, pause, try and find it, off you go. Right, so really easy to find. We just have a look at the matrix itself. So you've got two firms, small pizzeria, two firms, duopoly in a small town, very similar to kind of a setup I've used in a previous video. We've got one pizzeria called Can't Top This, and another pizzeria called Get That Base. So, we just need to look at the outcomes here. So Can't Top This has decision. They can either increase their prices or they can keep their prices the same. And the outcome of that decision, their profit outcome of that decision, is very much based on what Get That Base do. So they can either increase or keep the same. So if Get That Base decide to increase, they get 20. If they keep it the same, they get 24. So 24 is higher than 20, they'll keep that there. And if they keep the same, they've got 6 or 10. 10 is higher than 6, so their dominant strategy here is to keep the same. And then we just have a look at Get That Base as well. So what they will do, well, if Can't Top This decide to increase, they can either increase or stay the same. If they increase, they have 20. If they stay the same, they have 24. They'll choose to stay the same. If Can't Top This decide to stay the same, they can increase, they'll get 6, or they can stay the same and they will get 10. Well, 10 is higher than 6. So their dominant strategy is to stay the same. When both of them stay the same, then they will end up here. So this is our Nash equilibrium, right? Now, my question to you is that the tacit collusion position? Now, remember what tacit collusion means. So tacit collusion is just an unspoken agreement of where firms will set their prices so that they can be as the best off that they can be. It's not overt, they don't have a decision, they just enter the market, they set the price, and they collude based on what they think the other person is going to do. So think about whether or not you think that Nash equilibrium and tacit collusion position are the same. Well, that depends. It depends on kind of two things, basically. The first thing that it depends on is how many times they're going to play this game, right? So if they decide to play this game once, so they have one shot, set their prices, that's their price forevermore, they can never change it. And if that is their kind of rules of the game here, hence why it's called game theory, because we call them games, then Nash equilibrium and tacit collusion, their definitions very much line up, right? Because they will play it based on their one shot, right? So tacitly, they will also end up at the Nash equilibrium, because if they decide to move their strategy for firm B, Get That Base, from the same to increase, then they'll lose 4 units, 1,000, million, whatever, profit. And the same for Can't Top This. If they move their strategy to increase, they'll lose. So both tacitly and kind of Nash-wise, that's where they'll end up. But if they play the game again, right, so if they continue to play the game, so if they kind of go, okay, this round we both had same, what about next round, what about next round? Well, then it depends on our second kind of point here, and that depends on how much they discount the future, right? If they don't care about the future at all, if they're playing an infinite number of times, but they don't care about the future, they don't care about the outcome of the future, then they may well end up where the Nash equilibrium is also the tacit collusion equilibrium as well. But that might not be true if they don't discount the future, right? If they don't discount the future, then they may well end up somewhere else on this matrix. It may well be that the tacit collusion position actually ends up being up here, where they're both increasing their prices, and they can reach that tacit collusion without an overt agreement, right? And that depends on how much they discount the future. So we can think about it like this. They play their game as many times as possible, an infinite number of times, and they make a decision that actually they're going to start off with increasing their prices, right? They're going to start off by increasing their prices, and they're both going to get 20. So we've got kind of firm A, can't top this, and then we've got firm B, and they're round one, they both get 20, right? Well, 20, and then if they play that continuously every single round, well then they'll just end up with 20 times the amount of rounds that they go. And that might be where they end up. But as soon as one of them breaks that, as soon as one of them is enticed by this 24, right, then the other firm will react and they'll end up here at the Nash Equilibrium, right, and they'll end up making 10. So how long and that's what we call a grim trigger strategy, by the way. It's the idea that firms will tacitly collude, and then as soon as one firm breaks that, they'll move here and they'll end up getting 10, and then they will continuously play 10 forever. So how much they discount the future affects where their tacit collusion kind of ends up, and also how many times they play the game also depends on where their tacit collusion ends up. And if you want to spend some more time looking into that, I definitely implore you to have a look into thinking about how many times, or play around these numbers. You might make 20, 20, 20 and 10 and think about, well, 20 plus 10 is 30 for 2 rounds. Well, that's better than 10 and 10 of 20 for 2 rounds. So they could probably maybe get to an agreement, but is it better than 24 plus 10, so 34? So no, they won't be able to do that. Have a play around with the numbers, have a look at grim trigger strategies, have a look at infinitely repeated games if you're interested in that. It is so fascinating. And also very realistic, because firms don't just play this game once. It's not like Tesco's and Asda just set their prices once and then they leave them. This is far more realistic, in-depth look at this theory that you don't have to, or you won't be expected to recreate for your A-level. But it does lead us quite nicely onto game theory and the kinked demand curve, which is here. So when we look at the kinked demand curve, we're looking at one firm, right? It's one firm. In this case, we could choose firm A. It's one firm's demand, but that one firm's demand based on, or outcome is based on the decision of the other firm in the industry. So you have a kinked demand curve, and we know from our kinked demand curve lesson, if you want to go back to that and have a look at that before we move on, that's completely up to you, that this is quite a stable price, right? So firms kind of end up here, and then, if they increase the price, they make less revenue. If they decrease the price, they make less revenue. And we're going to use game theory to kind of prove that and have a look at that and see how that works. I've used PS because it's price and it's a stable price in oligopoly. You could have used P0 or P0 or whatever. And also I've filled all of these out. If you're not sure how I've logically got to all of these, have a look at that game theory. I think part 2 will help you kind of see how we fill these in. But what I'd like you to do is think about, is this price right here tacit collusion, or is it Nash Equilibrium? Right? I want you to just pause. I want you to think about whether this price here is tacit collusion, or whether it's a Nash Equilibrium, or is it both? Right? It can be both. If we look back, we know it could be both. And then we'll go through it. So we can do that here by looking at this. Now, firms do not make, it's kind of a misconception where firms have this idea where this is actually 2 different decisions. Firms first make the decision whether they keep the price or they increase the price, which is what we've got here, or they keep the price or they lower the price, which is the decision that we have here. Now split those 2 up, because you're only really expected to know about 2x2 matrices in the exam. You'll only be given 2x2 matrices in the exam. Kept a dominant strategy. Again, if you are interested in looking at game theory beyond that, you can have a look at mixed strategies. You can have a look at kind of where someone's got a dominant strategy, someone doesn't have a dominant strategy. Have a look at all of those, but I'm not going to go into them today. So let's have a look at whether firms should keep the price the same or lower their price to start off with. No, actually, let's have a look if they should same or increase. So firm A has the choice between same and increase, and what I want you to do first before I go through it is just have a pause, try and find the Nash equilibrium for both of these before I go through it, and then you can see if you're right and whether we've got those kind of down. So firm A has a choice between keeping the price the same or increasing the price, so price the same or increasing the price, and we're going to have a look at see what they're going to do. So if they keep it the same or increase, if firm B keeps it the same, they keep it the same, they get 10. If they increase the price, then they get 6. Well, obviously 10 is higher than 6, so they'll keep it the same in that situation. And if firm B decides to increase the price, if they keep it the same, they get 24. If they also increase, then they get 20. So obviously for firm A, same as their dominant strategy. And for firm B, they have a decision. If firm A keeps it the same, they get 10 or 6. Well, 10 is higher, so obviously they'll keep it the same in that situation. If the firm A decide to increase, 24 and 20, well 24 is higher than 20, so theirs is also, so therefore this is our Nash equilibrium. So at the moment, this price is looking like our Nash equilibrium, but then they also face the decision whether they should keep the price the same or lower the price. So let's have a look here again. If you haven't done it, pause that video, pause it and just find that Nash equilibrium and see whether this is actually tacit or if it's Nash. Now, what are we expecting if this tacit and Nash equilibrium are the same? Well, we would expect that this price here, which would be the decision to keep the price the same, would also be the Nash equilibrium. Is that true? Well, we can have a look here. So firm A, lower, firm B, lower, or the same. So let's have a look. So firm A, should they lower or keep it the same based on firm B's decision? Well, if firm B decided to lower, firm A has the choice of lower or the same. 8 is higher than 7, so they'll choose to lower their price. If firm B keeps it the same, 14 is higher than 10, so they'll choose to lower their price. Well, what about firm B? Well, if firm A decides to lower, you've got 8 and 7. Well, obviously 8 is higher than 7, so they'll choose 8. And then if firm A keep it the same, firm B have a choice between 14 and 10. Well, 14 is much higher than 10, so they'll choose 14. So then obviously lower is also their dominant strategy. So actually this is their Nash equilibrium. Is this the Nash equilibrium? No. The Nash equilibrium is to lower their price further. The Nash equilibrium here is to incite a price war, right? So actually this price here is tacit collusion, right? Now, and what that is, and it's almost maybe self-explanatory for you, but it's just where the firm is best off. They're almost balanced, they're waiting, and balance is definitely the correct word. They're kind of waiting to see which way they will have to go based on the other firm. This is the best position for them to wait and see and react to another decision based in the market, right? So this position, this price here, this quantity here, that operating position is their tacit collusion, right? Now, it doesn't matter kind of how they get there, whether it's a leader in the market setting that price, whether it's kind of like just an agreement, they just kind of hit it naturally. It doesn't really matter. What matters is that they stay there and they wait for other firms, and most of the time other firms don't really, unless they want to push somebody out of the market or incite a price war. Again, there's a video on price competition that you can have a watch if you want to look at why firms decide to go into price war or why they avoid going into price wars, which is more likely. And they end up here at this kind of tacit collusion position. Now, I'm going to show you this, I think, more clearly on a 3x3 matrix. This is not, it's kind of for fun, really, but it does help to explain this a lot more, so you need to carry on watching if you're one of my students. So, here we go. If you have a look closely, this is actually exactly the same as what we had before here. Same and increase, same and increase. So this here is actually the exact same matrix that we had previously. And lower and same, lower and same. Here is actually the exact same matrix. We just kind of put them together on a 3x3 matrix. You're not going to be expected to do a 3x3 matrix at your exam, please don't worry. But challenge yourselves, challenge yourselves to see whether you can find that Nash equilibrium position. Pause and see if you can find it. Okay, so I'm going to show you where the Nash equilibrium position is. It is here, that's the Nash equilibrium position. If you didn't get that, that's fine. but I would like you to have a go at pausing now and seeing if now you know where it is, you can work out why it's there. If you did get it and you got it kind of by accident, still fantastic, well done, really proud of you, but just make sure that you can justify it now that you know why, or kind of try and explain to yourself why. And if you got it and you know it, excellent, well done, congratulations. So let's have a look at why. And again, it's just those simple steps, like nothing has changed. It's still just those simple steps to looking at why this is our Nash equilibrium. So firm A has a decision to make, the same as firm B, right? They can lower, same, increase. Lower, same, increase. So the outcomes of that decision is based on what the firm B does, reacts to that decision. So firm A has a choice based on the outcome of firm B. So if firm B decides to lower their price, well, firm A has a choice between 8, 7 or 1. Well, 8 is the highest of those, so they will choose to lower. Well, what happens if B decides to keep it the same? Well, firm A has the choice between 14, 10 and 6. Well, 14 is the highest in those, so they will still choose to lower. And what happens if firm B decides to increase? Well, they have a choice between 25, 24 and 20. Well, 25 is the largest of those numbers, so their payoff is always best when they lower the price. It doesn't matter what firm B does, that's a dominant strategy. And again, we can just look at firm B. If firm A decides to lower their price, then they either have the outcome of 8, 7 or 1. Well, 8 is the highest of those, so it will choose to lower. If firm A decides to keep it the same, well then they have a choice of 14, 10 and 6. 14 is the highest, so they will choose to end up lowering as well. And if firm A increases, 25, 24 and 20, well, 25 is the highest of those, so they will also end up lowering as well. So therefore, that is the Nash equilibrium. But is that the best position for both of them on the board? No. I would like you to think about what is the best combined outcome on the board for both of these firms. So have a pause and think about that. Well, the combined best outcome is here, 20 and 20, but they would need to discuss that. They would have to set prices at an increase and increase. This is their overt collusion position. But where will they actually end up? Where will they set prices and wait? Well, that's their tacit collusion. Where do you think their tacit collusion position is? Well, it's here. This is the tacit collusion. And we can check this here by looking at this here. Well, firm A, because remember the Kinked demand curve is just for one firm, but the outcomes of profit for that firm are based on the other firm, which is what the game theory matrix tells us, but the Kinked demand curve tells us what the outcomes will be for that individual firm. So we can just have a look at that here. So PS and QS, well, PS and QS is our tacit collusion. We saw that on the last one. We're going to look here. So if they decide to have prices at PS, then they get 10 units of profit, millions, thousands, you know, whatever. But what happens if they decide to lower the price? So if they have price lowered here, well, what happens? So firm A is lowering their price. Well, if firm A lowers their price, firm B will also lower their price, right? So if firm B also lowers their price, then they end up with 8 and 8, right? So they've moved from the same and the same to lower, well, actually even if, and lower. So we end up at the Nash equilibrium. So here, when they lower their price from here to here, they actually make 8. And that fits in with the idea of them moving into something that's inelastic. They lower the price and the increase in quantity demanded is less than proportionate and they end up making less revenue. We can see that here, right? Well, what happens if they increase their price, say here to PH? Well, we can have a look on here and see that actual outcome. So firm A decides to increase their price, so they've moved to PH, which is a higher increase, well, even if firm B decide to keep it the same, they end up with 6, or if firm B decides to lower, then they'll end up with 1. We'll assume that they keep it the same. Either way, firm A's profits have dramatically fallen. We'll presume they keep it the same, and they move to 6. Well, they've increased the price, they've had a more than proportionate shift in of their quantity demanded, and they've ended up with less revenue. So all you really need to understand is that actually the kinked demand curve is one firm's outcomes of these positions, right? So these two pieces of theory are intrinsically linked. They just show one firm's outcome of the different positions here, right? They show the reactions to the firm, and you can see that when it's 2 by 2. It's easier to see when it's a 3 by 3. But thinking about the exam, how does this apply? You won't be asked to kind of look at this 3 by 3 matrix or to go into depth with that, but you may well be asked about price setting, where you can use either of these pieces of theory. It's not going to be explicit of which one that you're going to use, and it's up to you to decide which one it fits in. But you need to understand that they're essentially kind of showing the same things. This is showing the whole market outcome, right, for both firms. So this just shows what is going to happen for both firms in the market, whereas the kinked demand curve just shows what's going to happen for one firm in the market. So firm A's outcomes, whereas the game theory matrix shows the outcomes for firm A and firm B, right, combined. So that's it for today. I hope that you've enjoyed it. Next lesson we're going to have a look at some exam questions and where you can fit this in. I hope that you've enjoyed this. I've definitely enjoyed teaching you. Thank you so much. Have a good day. Bye.